Welcome to the first video for Chapter 5, and most of you are probably coming back from winter break, so I'm glad you're back. Let's try to think about some math and some trig. You haven't done that for a couple weeks. This is notes for 5-1, the lesson 5-1, and we're going to make it day 1 because we're going to spend 2 days on this. All of these trig identities you need to memorize, and some of them may seem very familiar to you, so they won't be as hard as some of the others. If you'll notice the top 2 groups, this says sine of 90 minus theta. This is sine of pi over 2 minus theta. They're the same thing. So you don't really need to worry about memorizing both of these as something so different. If you'll notice, sine always goes to cosine, cosine goes to sine, secant with cosecant, etc., tangent with cotangent, and so those will be easy. These you already know. Those should be easy too. This is going to be the big one that you're going to need to focus on. And even the even identities and the odd identities, you've done these before. Remember, when we have even identities, they have y-axis symmetry, and the odd identities have origin symmetry. Remember when we talked about the even identities, I drew a circle and we said if you have an even, or a positive theta, you come up here, and then if you go to the negative theta, they have the exact same cosine value, x value. So here it has a t instead of a theta. It's the same thing. So we also remember from your favorite unit when we did graphing. I know I'm being facetious. You didn't like that unit. But remember, this is a cosine graph. That cosine graph is symmetrical to the y-axis. That's why it's even. And also, if we come to each of those minimums and those maximums and we draw the secant, remember, it also is reflective over the y-axis. So remember, the cosine of a negative value is the same thing as the cosine of the positive value. Now, let's talk a little bit more specifically about this main Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. That's the big one you need to remember. Also, you need to remember that they need to be squared. You cannot come over and say sine theta plus cosine theta is 1. Okay, that is not valid. They must be squared. Okay? This isn't anything new, really. When we had our triangles and we had the cosine value and we had a sine value and we had a 1 for the radius, it was a unit circle, that's a right triangle. We would say cosine squared plus sine squared equals 1 squared. Now, if you notice, I flipped the order here, but remember, addition is what we call commutative, so I can have cosine first plus sine squared equals r squared, the radius squared, the hypotenuse squared. So this is not anything new. This is just in a form that we haven't used before. Also, if you come over here and write it kind of small, I'm going to show you a little trick. If you take each one of those terms, and if we divide each one by cosine squared, we are dividing each term by cosine squared, so it's perfectly legal. as long as we do that across the board, right? But what is sine over cosine? Why, that's tangent. And sine squared over cosine squared is tangent squared. Plus cosine squared over cosine squared is 1, anything over itself. 1 over cosine squared. Well, 1 over cosine is secant. 1 over cosine squared is secant squared. Well, look at there. Look at what you just derived. You just derived the second Pythagorean identity. And you can likewise do the same thing if, let's see, if we divide by sine squared this time. Sine squared, sine squared. Sine squared divided by sine squared is always 1, plus cosine squared over sine squared. Now that's cosine over sine, which is cotangent, but we're squared, so we have cotangent squared equals 1 over sine squared. Well, 1 over sine is cosecant, so this is 1 over sine squared is cosecant squared. And look at there. We just derived the third equation. So I don't want you to think this is insurmountable to memorize. You can break it down into pieces, and you already learned quite a bit of this. And these you can derive if you forget. Now, I also want to talk a little bit about manipulating some of these. If I look at this main equation right there, and if I manipulate that such that I have 1 minus cosine squared, okay, think in your head, if I've got 1, I subtract the cosine squared to the other side, I'm left with sine squared. Well, there's another form of this identity. I didn't write this on the paper because this can be derived by looking at this. You can manipulate that. Let's try another one. What about sine squared minus 1? That would be negative cosine squared. Try another one. 1 minus sine squared. So I move the sine squared to the other side. That equals cosine squared. Cosine squared minus 1 is equal to negative sine squared. Now, all of these manipulations you can also do with these two identities. I'm not going to write these down and expect you to memorize each one of these, because if you understand this identity and this sum, you can get all of these when you need them. Now, when you're working these problems, these give you the tools to simplify and manipulate things. You need to get to the point that you see them and you know immediately what to do. If you see one of the terms that's squared, you need to see if you can use one of these identities. If you see 1 minus, or the value squared minus 1, you can think maybe I can use one of these identities. This is sine squared plus cosine squared. Do you think that we can also take the difference? Okay, what would that be? Okay, you can't do anything with this identity-wise. You can factor it, right? You can have sine minus cosine and sine plus cosine. Left my theta out. but you can't use an identity because it's a difference. So pay attention to some of the things to look for that can trigger how to use some of these identities. Now what I'm going to do right now is I'm going to work through 5 examples. These are examples that we did in class and we went through the notes, but if you're absent, that's why you're watching this video, or if you just want to go over them again. So I'm going to do these examples. I may need to go into the other video just to finish up, but these will help you get some tools for how to simplify and how to work with some of these identities. Here we go. Example 1. We are going to find cosecant and tangent given that cotangent is -3 and cosine is negative. Okay? So we want to find cosecant and tangent given these pieces of information. So the first thing we need to do is figure out where we're operating. What is our quadrant that we are working in? If you have cosine that's negative, remember cosine is x, so you're operating in quadrants 2 or 3, the left-hand side of the circle. If you have a cotangent that's -3, cotangent, remember, is cosine over sine. So one of these has to be negative to give me a -3. That means I can't have them both negative, but one has to be negative, which means I am in quadrant 2 or 4. Well, 2 is our winner. They both have 2. We draw a triangle. We go into quadrant 2. Theta is always in the corner of the origin. And cotangent is -3 over 1. Well, tangent is opposite over adjacent, so this must be adjacent over opposite. You can also think of cotangent is cosine over sine. Remember, cosine over sine. Cosine value is your x, sine is your y. Okay, I'm in quadrant 2, so just make sure that this is negative, and it is. Now I need to figure out my hypotenuse. Do Pythagorean Theorem. You're going to have -3 squared plus 1 squared equals our unknown squared. Well, that gives me 9 plus 1 is 10, and then I would take the square root. So this is the square root of 10. Once you have all 3 sides, you can do any of the 6 trig functions. I only want cosecant and tangent, right? So cosecant of theta is 1 over the sine. Okay, it's the reciprocal of sine. Well, sine, remember, is opposite over hypotenuse. So this would be hypotenuse over the opposite. So I have the square root of 10 over 1, which is square root of 10. Also want tangent. Tangent theta. Remember, that is sine over cosine. That's opposite over adjacent. So you have 1 over -3 or -1/3. Same thing. Now you've done this before. This is not new. Here we're introducing some of these identities, but it's the same thing. Figure out which quadrants you're in, get the missing sides, and then you can figure out any of the values. Okay, I'm going to stop the video here, and then we'll do the other 4 examples in the second video.